Good morning, afternoon, whatever it is for you. This is day 9 of the stats unit. It's the last new lesson. Please do not watch this video until you've done the 3 previous videos for day 6, day 7, and done the homework. You'll be a little lost. You might be lost anyway, but you'll be a little lost if you don't have those three lessons done. So please do these in order. Assuming that you have done them in order, let's get going. So now we have some real problems, and we're going to apply what we've known from before. GPAs of seniors in high school have approximately normal distribution with a mean of 3.38 with a standard deviation of 0.28. What is the probability that a randomly selected senior has a GPA of at least 4.2? A couple things that we want to look at with problems like this. We see normal distribution, and it pretty much tells us, you know what, we need to draw a curve. Okay? And we might want to label it with our mean. 3.38 is going to be right there. And then our first standard deviation is going to be at 0.28. More than that. 3.38 plus 0.28. Calculator here. It's going to give us 3.66. Another one's going to be 3.94. That's 2 standard deviations. And another standard deviation would be 4.22. So we are looking at 1, 2, almost 3 standard deviations above the mean. The score we're looking for right there is 4.2. So we want the probability that our GPA is going to be greater than 4.2, according to this data. Well, that's not going to be a lot of people. I can tell you that right now. The shaded portion of this curve is just going to be right there. That's not going to be a lot of people. It's not going to be a big probability. So we're looking for a pretty small number. Okay? So let's turn these into a z-score so we can look up the probability on our z-table. So I have to take my z formula. The data point we want is 4.2. The mean is 3.38. And we're going to divide by our standard deviation of 0.28. Again, what z does is it tells you how many standard deviations you are above the mean. 2.93. That's rounded to 2 places. So this score, it's almost 3 standard deviations away. It's 1, 2, and 3. It's just in front of 3 standard deviations, and so you get this z-score of 2.93. We look that up on the table. 2.93 is down at the bottom of the positive sign. 2.90, 2.91, 2.92, 2.93, 0.99831. Now remember, that is the probability of being to the left of that. We want the area that's to the right of the 4.2 because we want greater than. So we need to go 1 minus 0.99831. 831. So the probability that our GPA is over 4.2 0.00169. Not a lot. Less than 1%. Next question. The recommended GPA to apply for a university out of high school is 3.0. What is the probability the randomly selected senior does not meet the GPA requirement? Okay, so let's draw that curve again. And we'll label it with the mean, which is 3.38. We have a standard deviation. First standard deviation would be at 3.1. That's the 3.38 minus the standard deviation of 0.28. 3.38 minus 0.28 is 3.1. Minus another 3.1 or 0.28 would be 2.82. So again, the recommended GPA for applying for university out of high school is 3.0. 3.0 is going to put us right about here. Okay, that's 3.0. And we want the probability that a randomly selected senior does not meet the GPA standard. So what we want is we want this area here. We want the GPAs that are less than 3.0. So again, we want the probability that our GPA is less than 3.0. And we'll have to use our z-score to find it. Remember, x minus mu over standard deviation. So our score is 3.0 minus our 3.38 mean or mu and 0.28. That gives us a negative z-score of negative 1.38. What that means is that our z-score is 1.38 standard deviations less than the mean. So here's one standard deviation, and then this little section right here is the 0.38. So what this is our z-score for 3.0. That gives us 3.0 is 1.38 standard deviations less than the mean. All right, to turn that into a probability, we look up that z-score on our table. Negative 1.38, that's the positive side. Now here is the negative side. Negative 1.3 is where my pen is. And then all the way over here, the second and last column is the 8 column. So negative 1.38 would be 0.08379. 0.08379. Make sure that's right again. Yeah. So the probability that a GPA of a randomly selected senior does not meet the GPA requirement of 3.0 is 0.08379, which is 8.3%. Okay. What is the probability that a randomly selected senior has a GPA between 2.99 and 3.42? I always suggest that you write out a picture and you label everything and shade what you're looking for. Okay? So, again, this is the same situation. We have 3.38 is our mean. Standard deviations, we'll have to go back to 2.99 and all the way up to 3.42. So if I go back one standard deviation, I get 3.1. And if I go another standard deviation, I get 2.82. Going forward from 3.38, I get 3.66. I'm copying these numbers from the previous two problems. So 3.66 and 3.94. Don't need to do the 3.94 because 3.42 is going to be in there. So 3.42 is going to be right about here. Whoops, no, it's going to be right about here. And 2.99 is going to be right in here somewhere. So I want this area here. So just a little bit in front of the mean, more than the mean, all the way to more than one standard deviation less than the mean. So to do this, probability to get our GPA between 2.99 and 3.42. This is for a randomly selected senior. I'm going to have to get the probability of that GPA being less than 3.42 and subtract that from the probability of GPA being less than 2.99. Again, what I'm doing is I'm taking the area to the left of my pen. That's everything. That's the red and this section over here. Okay? To get just the red section, I'm going to take everything from the left of my pen, and I'm going to subtract off everything to the left of where my pen is now. So I'm going to get the entire curve to the left here, and then just the tail here. Subtract the tail off from the entire curve from the left of my pen now, and I'm going to get just the red part. So I got to do two different z-scores here. So the z-score for the 2.99 is going to equal 3.38. Excuse me, and that's not right. 2.99, sorry. 2.99 minus 3.38 and divide it by 0.28. Okay. The score we're looking for, the 2.99 minus the mean divided by the standard deviation. And then the z-score for the 3.42 is going to be, oh, I messed that up. 3.42 minus 3.38 divided by 0.28. It's been a long day already. I think I'm learning more than you guys are. I'm certainly at it every single day. Some of you guys are at every single day. Some of you guys are kind of trying to avoid what's going on. Hope that you guys figure that out pretty quick. Sorry, I'm going to get back to math now. No more banging on you for not doing education stuff. Okay. So the 2.99 minus the 3.38 divided by 0.28 gives us a z-score of negative 1.39. And then my z-score here, 3.42 minus 3.38. Divide the whole thing by 0.28, you get 0.14. Again, those are all rounded to 2 places after the decimal place because that's what the scale goes to, the table. All right, so a z-score of 0.14 is this one. 0.14, 0.10, 0.11, 0.12. Oops, not on the page there. 0.01, 0, all the way over to 4 here, 0.5567. So 0.55567. And then the z-score for the negative 1.39, negative 1.39. So negative 1.3, all the way over to the last column, that's where my finger is, 0.08226. Okay, so let's see if those probabilities make sense. If I was to go from this point to the left, that's from this point to the left, that would be the 0.55567. That is 55% of the curve. That's just more than half of the curve, and so that's right. And then the 0.08226, well, it's from this point to the left. So that's 8% of the curve. Okay? So to get what's just in the red, subtract the 2, and looks like 0.47341. So the probability is 0.47. That means 47.3% of the curve is there in the red. Sorry, we're off screen there a little bit. So not much has changed. I do it at school all the time, and you guys are always telling me. I figured it out this time. So, all right, that's the first 3 problems on the homework, or excuse me, on the notes. Let's take a look at example number 2. A normal distribution of scores has a standard deviation of 8. Okay, so we're looking at, for the rest of this problem, we're looking for a standard deviation, a sigma of 8. Find z-scores corresponding to each of the following. Okay, all right. A score that is 8 points above the mean. Let's do it this way. Let's say our mean's at 0. Just make the calculations. Okay. That first standard deviation is going to be at 8 and negative 8. And then negative 16 and positive 16. Okay. So our standard deviation is 8. So the width between the mean and where the first standard deviation is, that's 8 units. I started at 0, so I went to 8. Now, I want a score that is 8 points above the mean. 8 points above the mean would be right there. Well, that means it's 1 standard deviation. The distance between 0 and 8, when the standard deviation is 8, is 1 standard deviation. And that's what the z-score is. Z-score is the number of standard deviations. So my z-score there would be 1. Score that is 24 points below the mean. I got to go out another standard deviation here to get to negative 24. And that is 1, 2, 3 standard deviations. So if it's 24 points below the mean, that's 3 standard deviations. So our z is negative 3. 3 standard deviations below the mean. So that would be minus 3. Score that is 20 points above the mean. All right. Well, remember our z formula. I'll do it up here. Our z formula is x minus mu over standard deviation. X, we went 20 points above the mean, so 20 minus the mean, which would be 0 in this case, divided by the standard deviation. So 20 minus 0 is 20 over 8. And then we reduce that, 10 fourths, 5 halves, that's 2.5. The z-score is 2.5. Okay? Z is 2.5 standard deviations above the mean. That's what z is. The score there's 12 points below the mean. So negative 12, our mean is at 0. 12 points below the mean would be right about here. Okay, so negative 12 minus 0 over our standard deviation. So negative 12 divided by 8, which is negative 1.5. And folks, that is it. Do the homework. I'll have keys for days 8 and 9 soon. We're going to be transitioning to new stuff, not data, soon. I'm going to figure out how to do some sort of an assessment. We'll probably do a quiz based on what we've done online very quickly. Next couple of days. This will be the last assignment for this week.